Welcome to a tutorial for longitude and latitude. In our learning objectives for today is one, that we want to learn the vocabulary of longitude and latitude. So we want to understand the words that are associated with it. We want to understand what we're talking about when we talk about degrees, the equator, prime meridian, and things like this. Two, we want to have an understanding of how and when to use longitude and latitude. Three, we want the ability to apply what we know about longitude and latitude to any map that we use. In today's lesson, we're going to do three things. One, we're going to read from the book. We're going to find some definitions and see the rationale behind using longitude and latitude, how it was created, where it comes from, and you'll see that mathematically it makes very much perfect sense. Then we're going to look at longitude and latitude in practice and how we use it on our maps, especially what we're going to be doing in the classroom from day to day. And then we're going to look at some real maps that we're going to be using, and I want to just identify some differences and similarities so that we understand that while all maps have it, they're not always going to look perfectly or be used perfectly the same. What you should be doing at home or with your iPad right now is either using a notebook or a packet that you may have been given by your teacher to write down notes. I want to remind you guys, you're going to be looking for highlights and things that I'm writing throughout this video, and you're going to use this as a guide to know when you should be writing something. If I'm focusing a lot on it, you should be taking notes about that as well. Alright, first thing I want you guys to notice is the terminology, longitude and latitude. Alright, these are what we are going to be discussing throughout this video, longitude and latitude. So if nothing else, you need to know what these mean before we leave. Alright, and you want to practice with these as I go through them. Now, I'm not going to read everything on this page, but I am going to make sure that I read some of the more important things. So, for example, I'm going to start down here. So I'm going to start down here, and I'm going to start looking at this idea of the lines of latitude are parallel to the equator. The global grid system is made up of two sets of imaginary lines. The first set of lines, or parallels, of latitude run east and west around the globe. Now I want you to pay attention to this idea that while they run east and west, east to west, all right, they actually measure north to south. All right, this is a little bit tricky, but once you start to see this and you mess around with it a little bit more, it's going to make a lot more sense. Now, another thing that I want you to pay attention to is the fact that they say that these are parallel. For something to be parallel, it means that it is two equal lines from apart from each other and that they never intersect. So if we look at the equator here, and we look at 15 degrees north, these two lines are equally apart from one another and will never intersect. So there are two separate lines. So I want you to notice the circle that I've drawn, or the oval I should say, the oval that I have drawn here. Each one of our lines of latitude is an oval that circles around the Earth. Now the equator is the most important parallel of latitude. It circles the Earth exactly midway between the North and South poles. All other lines of latitude are parallel to the equator. Parallels of latitude are measured in degrees, with the equator marking 0 latitude. Other parallels are measured with reference to the equator. In other words, what they're saying here is that if our equator is 0, we are trying to measure how far away from 0 each one of these lines are, all the way up to 90 degrees. Does everyone see that this line right here is going to make a perfect right angle all the way to the North Pole, and the South Pole being 90 degrees away from the equator? All right, so the equator is here. This line is 15 degrees away from the equator, 30 degrees away from the equator, and that's what this cutout shows us, measuring as like if we were to use a protractor, 30 degrees away from the equator. 45, 60, 75, and then at the very height is 90 degrees. And notice, on my little note over here, I wrote that latitude is a circle, a full oval circle, measures from 0 degrees to 90 degrees, the equator to the north or south pole, and it measures north or south from the equator. Lines of longitude, however, run from pole to pole, and I'm going to explain what that means in just a minute. The other set of lines in the global grid are half circles called meridians of longitude. Now, the fact that it's a meridian means that it's not, or that it's going to run into each other. If we look at our diagram down here, all right, what I want you to notice is that these lines bulge out towards the middle and then intersect at north and the south pole. Now, just like our lines of latitude, these lines run north and south, but they're measured in east or west. All right, and so this diagram right here is showing you that idea that these lines are only half circles, and at the north and at the south pole they actually change, and on this side they're actually a different line. Whereas latitude runs from 0 to 90, longitude runs from 0 to 180. All right, mathematically speaking, if we had 0 to 90 and 0 to 90, there would be two locations with the same exact numbers. And what this does by creating it all the way to 180 is it makes sure that no two places have the same exact coordinates. All right, but I want you to remember that these are meridians. Now, the most important meridian is the prime meridian, and this runs through Greenwich, England. Now, the only reason why this runs through here is because when the map was created and longitude and latitude were created, England was the strongest country in the world. It was arbitrarily chosen. There's no significant reason that this line was chosen as 0. All right? Just like our lines of latitude, our lines of longitude measure our degrees away from this prime meridian in 0. So for example, if I were to take a protractor and measure 30 degrees away from the prime meridian, that's where this line is created from. And these lines are going to go all the way from 0, again, to 180, which is known as the international date line. All right? Now, one interesting fact is at the international date line, when you cross over, you actually cross into a different day. Travelers moving west across this line go forward a day, while those going east go back a day. All right? So when we combine these two things together, they're going to give us an absolute location. Now, an absolute location is one that we can find absolutely. When we look at this in longitude and latitude, it's going to look something like this: 20 degrees north by 85 degrees west. Now, when I'm given those two numbers, I can find any location on the Earth. All right? So what we're going to do as we move on is we're going to talk a little bit more of how to use numbers like this. So now look down here. Longitude and latitude mark absolute location. The numbering system of the global grid helps make it easy for you to locate any place on Earth. Moving north from the equator, the parallels of latitude increase in numbers from 0 up to 90 degrees north at the North Pole. A similar thing happens moving south of the equator, where the numbers of the parallel increase from 0 to 90 degrees south at the South Pole. 1 degree of latitude covers about 69 miles or 111 kilometers. Meridians of longitude start at 0 at the prime meridian. Traveling east from there, the number on the lines of longitude increase until they reach 180 degrees at the international dateline. These numbers are labeled east. The same thing occurs going west from the prime meridian. The numbers increase until they reach 180 degrees at the dateline and are labeled west. The absolute location of any place on Earth can be described as the meeting point of parallel of latitude and the meridian of longitude. The numbers of these lines are geographic coordinates of a plane. These coordinates are like a street address for your house. They tell you exactly where a place is located. So for example, if I'm looking at the car, all right, and I were to ask you guys, what is the address of Dakar, we can use longitude and latitude in order to find that. Now I want to just point out a few things to you here before I actually go through and do that. Number one, I want you to identify where the equator is at. Let me just move that out of my way. Our equator is at 0 degrees, and this is our line of latitude. Remember, one of the easy ways to remember this is lat equals flat. My flat lines are my lines of latitude. All right? Now, my longitude, all right, run pole to pole. Or as I say, they measure you as long. So think about it. If you're going to measure how long or how high you are, you're going to measure from here to here. And so you're going to do it this way. All right? So that's how we can remember those. Let me just erase this. So we always want to start out by looking at the equator. And what we want to remember is that when we measure away from the equator, we measure up is north, and then when we measure down is south. Now, where this gets tricky is when I'm moving up from north, I'm measuring 1, 2, 3, 4, 5, 6. But when I'm measuring south, I'm measuring down 1, 2, 3, 4, 5, 6. All right? And where students often make a mistake is, let's say I ask you to go to 50 degrees south. They find 45 and then move up from it, because that's what we're typically used to doing. All right? You have to train your brain to remember that as I look at 45 degrees south, I have to move below this line to where that 50 degree mark is going to be. Similarly, we're going to measure from the prime meridian the same way. If we look at our prime meridian, which is right here at 0, all right, moving this way, we're moving east, and again, we're counting up. All right, moving this way, we're moving west, and again, we're counting up to the left. Again, this is one of those areas where you have to train your brain to remember how to measure in that area. Longitude is measured in much of the same way. If I'm looking at the top of the map and I find my prime meridian and I look to the right, I am measuring east. Now these numbers run normally like what we would look at, where we count from left to right: 15, 30, 45, 60, 75. If we look to the left of the prime meridian, we're measuring west. All right, now these work differently. This one we're reading right to left. So 15, 30, 45, 60, 75. Notice that I have to move right to left. And again, this is an area where most students make mistakes, because this is where we start to see some problems. So now let's look at a few places here. All right, we're going to start out with Dakar, which I had mentioned before. Notice that Dakar is right here. If I am looking for the absolute location in longitude and latitude of Dakar, I have to first start with the equator, 0 degrees. And then what I'm going to do is I'm going to measure how far away from 0 this is. And whenever I give my longitude and latitude, there is a specific formula that we use. All right? We are always going to have latitude, comma, longitude. And we'll practice using this both ways. So the very first number I always give is latitude, or these flat lines. So as I look at Dakar, I'm trying to determine how far away from the equator is. Well, we're pretty lucky on this one because Dakar seems to be right on this line. So I look to the left of this line and I find that it is 15 degrees north. I have to put that circle up there at the top and then north, and my comma's already there. Now I want to start looking for my longitude. Now for my longitude, I'm going to measure how far is Dakar away from the prime meridian. And what I want you to notice is it's not directly on this line, this longitude line. It's a little bit away from it. All right, so as I work up, I see that that's 15 degrees west, but I'm not quite at 15 degrees west, so now I have to do a little bit of determination of what is the exact coordinate. And I see that this is 50, and then this line is 30, so a little bit higher. I want to say this is probably 16 to 17 degrees west. And I'm going to go with 17 degrees west. Now, as I look at here, there is no 17 degrees west. I have to assume that even though the numbers are not all written, that they're still present on this map. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right? I assume that all of those numbers are there even though they're not written. And that's going to help me find a location. Another one that we can do, St. Petersburg. St. Petersburg. All right? St. Petersburg is right here and is at 60 degrees north, and I know that because I followed from 0 all the way up to 60, followed that line across, and there's St. Petersburg. All right? So 60 degrees north, and then it is at, here it is here, I measure away from the prime meridian all the way over to 30 degrees east. It is extremely important that I always keep those directionals in there. We have to have that north. We have to have that south in there. All right, so now that we've done two easier ones, let's look at one that's going to be maybe be a little bit more challenging. And we're going to use Melbourne. Melbourne, which is in Australia, right down here, I can see is not on any line. All right? So what we're going to have to do is we're going to have to estimate a little bit. Melbourne, if I start out at 0, the equator, and I measure down, and I'm going to take this over, and then I'm going to use these numbers over here to try to determine where Melbourne is at. Sometimes using a ruler makes this a little bit easier, especially when these maps are square like this. All right? And so if I look over here, I'm going to say that Melbourne is, let's say, 38 degrees south. Now, if you were to be off plus or minus, let's say 2, you were to say this is 36 degrees south or 40 degrees south, you would be within justifiable numbers. However, if I'm going to go through and say that Melbourne is 45 degrees south or 30 degrees south, that would clearly be wrong. 31, 35 degrees south would clearly be wrong. All right? So would 44 degrees south. All right? When we're doing this, we are going to estimate, and so we're going to give some leeway when we come up with this. In other words, there's some give here. We understand that we are estimating here. All right, so now that I have my latitude, now let's find my longitude. If I'm going to measure how far away from the equator is, I'm going to measure up to these numbers, and I see I'm in between 135 and 150. I'm going to say that this is somewhere around 145 degrees east. Again, all right, you might look at this and think that that is a little bit different. Maybe you see it as more of 142 or 140 or maybe, something in that nature. All right, it is fine for you to be plus or minus a little bit. All right, what we don't want to do though is we can clearly see that 150 and 135 are wrong. All right, so we want to err on the side of caution and make sure that we're using this appropriately. Now I wanted to look at this just for a moment because I want to show you this idea here. As we count from our equator, which is 0 degrees, right? Each line is present. 1, 2, 3, 4, 5, 6, 7. But when we look at a map, it's not going to look like this. Instead, what they're going to do is they're going to count, all right, either by tens, maybe 10, 20, 30, 40, 50, or maybe by 15s, 15, 30, 45, 45, that's why, 60, all right, 75. And even though there's not one of these dashed lines for each number, we know that they're present in this area. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 10 or all the way to 15. All right, and what you have to do is as you look at a map, you have to adjust your estimation based on what this difference is, realizing the whole time that the numbers are still there. Now, when I move up this line, I'm counting as I normally would, counting up, counting from top to bottom. And this is how our brains have been trained since we've been a little kid, is to count this way. Where we struggle is when we have to count down. So when I'm going 1, 2, 3, 4, 5, all the way down, and I have to find 2.5, all right, often I want to put that 2.5 there. I have to remember, though, when I'm below this equator, I have to count down. The same is true when I'm on this west side of the prime meridian. All right, so I just wanted to show you guys that, just so you realize that all numbers are present. If every number had a line on a map, we wouldn't be able to see everything, and that's why they're estimating, and that's why they kind of count by 15s, 30s, 20s, 10s, or whatever else it may be. Now let's look at a few different maps. The first map that you guys are going to be using in a mapping lab is going to look like this, and it's the map of Canada and the United States. All right, now I've specifically chosen this map because I want to show you how a map distortion is going to try to correct some of that by representing the curvature of the Earth and how that's going to change how you find longitude and latitude. All right, and so what I want you to notice here is as I look at 10, 20 degrees north, 30 degrees north, 40 degrees north, 50 degrees north. All right, these are my lines of latitude. As I look at these lines, and I were to tell you to find 40 degrees north latitude, not so bad. I stay on my line and I can follow it all the way around. However, if I asked you to find 45 degrees north, that might present a different challenge. Because if I were to do, like I've been doing in the maps that I've been showing you, and I were to find 45 and make a straight line across, I want you to notice that I am crossing a line here. I am now above the line here and crossed it back over here. This line is not parallel and therefore does not work. I have to notice that sometimes maps are going to look a little bit different, and I need to remember that lines of latitude are parallels, which means that I have to stay an equal distance away from that line in order to be at 45 degrees north at all times. Additionally, if I look at my lines of longitude, they run very similar as well. Now, the difference here is that if I'm looking at my line, let's say I'm looking for 105 degrees west, Notice how much smaller that area is between the boxes as opposed to here. All right, so I just have to keep that in mind as I'm estimating. My estimates in this box, all right, of distance halfway between are going to be very different from this box. All right, so we have to keep these things in mind as we look at our different maps. So this map has a lot of curvature. Look at 80 degrees north, 70 degrees. I mean, we're making a U shape. And the reason being for this is because we're up by the North Pole. And so think about if you were looking at a globe, all right, and we were looking at this, all right, this is what it would look like. So this map is trying to reduce the amount of distortion of size and shape, especially in these northern regions, and therefore showing you that curvature. Now the next map I'm going to show you is more towards the center. This is a map of Monsoon Asia. And as I can see, my equator is right here. And if I look at my lines, they're much flatter. And that the reason for that is because I'm only going from 0 to 50. In my last map, I was looking at from 20 to almost 90. And so as I looked at that, those lines had to be a lot more curved in order to reduce the amount of distortion. This map, all right, I noticed that my lines are much flatter, especially as I get towards this equator. I can run a straight line across. And again, I'm not intersecting here, right? I'm not exactly parallel, but I'm much closer to parallel than I would have been. I also notice that my boxes of my longitude, all right, there's not a biggest variance between them. In other words, my shape is not getting way smaller from here to there as my other one did. So these are all things to keep in mind. Your teacher should be providing you some practice going forward to use your longitude and latitude. One thing I want to also remind you is if you are struggling with longitude and latitude at this point, remember, that's okay. This is your first time using it, and as you use it throughout the year, you'll get better and better and better. There'll be multiple opportunities for you to practice using longitude and latitude so that you'll get better over time.